Hi, this is Mr. Gubernal. I'm going to go over the E through I on that graphing medley. I made a bunch of mistakes on E through I when I was doing the video, so I just wanted to clean it up. I'm hopefully downloading the trim part. If it doesn't come up, then what is going to happen is I'll have you watch the video and just watch a portion of it. But I'll post that in Google Classroom when it comes time. Okay, so we're going to go over to here and we're going to re-look at this function. So we're at h of negative 2, f of negative 2, or h prime of negative 2, and h double prime of negative 2. So the first thing that we're going to do is find f of negative 2, or h of negative 2. So h of negative 2 is going to be 2 plus the integral from negative 2, and since this is x, this goes to negative 2, of f of t minus 1 dt. So I'll come over to that in just a second. Well, anytime that you have a value, a and b value, that are the same, then what happens is that becomes an area of 0. So this would be 2, and that is the value of h of negative 2. Okay? I'm going to come right back to, all right, so h prime of negative 2. So I need to take, for this one, I need h prime of x, which means I need to take the derivative of this function. And the derivative of this function is going to be 0, and then plus, and the derivative of this function is going to be f of x minus 1. Because when I take the derivative of an integral, it's going to cancel it out, so it's just going to be left with this. So h prime of negative 2 is f of negative 2 minus 1. And f of negative 2 is 0 minus 1 is negative 1. All right. And the second derivative, so the second derivative is equal to the slope at negative 2. So if we have h prime of x equal to f of x, then the second derivative is the derivative of f, and that's the slope of f at negative 2. So the slope of that line has a slope of positive 2. So I need the slope of f at negative 2, and that is 2. So h double prime of negative 2 is negative 2, or positive 2, excuse me. Okay. F. All right, f. They want h of 0. All right, so now they're getting into this same function. And any time that I see an x, I'm going to replace with 0. F of t minus 1 dt. Okay, so what we're going to do is we are going to find the integral of that. But what we're going to do, oh, that's a 0. We're going to break this apart. So we have 2, and then we're going to go from negative 2 to 0 of f of t dt minus the integral from negative 2 to 0 of 1 dt. So what this does is it gives you 2 plus this area. Now this area under the curve is from negative 2 to 0. It is this blue triangle right here. It has a width of 2 and a height of 2, and this is going to be 1/2 of 2 times 2 minus, and then this would be what? X from 0 to negative 2, which is going to be a negative 2, right? Minus, yeah, 2. So just making sure I get 0 minus a negative 2, which is 2. So it's going to be minus this minus right here and that 2. And this will give you 2 right there. Plus 2 minus 2 is 2. This is h of 0. It's going to come into play in the next one. H of negative 5. Well, that's 2 plus negative 2 to negative 5. F of t dt, or f of t minus 1. These were the little mistakes that I was making in the other one, not moving it up. So that's what I get. Now, if I'm going from negative 2 to negative 5, I'm going backwards. And we talked about that earlier, that if I'm going backwards, I want to make sure I can move forward. So if I want to change that direction, all I'm going to do is go in the opposite direction. So that opposite direction is going to make this become negative out here. Alright, then I'm going to split. Alright, so I got to keep this all in kind of a negative situation. Negative 5 to negative 2 of f of t dt minus negative 5 to negative 2 of 1 dt. Okay, so I'm looking at this, I get 2. Alright, so minus this area right here, negative 5, so this is an area of 1 and this has an area of negative 2, because I'm going left to right now. So this has an area of negative 1, this minus, this has an area of 3. So I have 2 minus a negative 4, which is 6. Okay. H of negative 5 is 6. Alright, G is asking for the equation of the tangent line of h of x at x equals negative 2. Alright, so x at negative 2, I need to know what h of negative 2 is. And I do believe I had that. H of negative 2 is 2. And I think I had the slope at negative 2, which is negative 1. So h negative 1 is, or negative 2 is negative 1. So here's my equation. Y minus 2 is negative 1 times x plus 2. That is the equation line of the tangent. If it said approximate, then I'd throw in a number. That's the only thing that you need. If you wanted to clean that up a little bit, you could go negative 1 times x plus 2 plus 2. Sometimes you'll see it as this, 2 plus a negative 1 times x plus 2. That's another way to look at it. I would just leave it like that because that is an equation of the tangent line. Alright, so we're on to H. We are on to H, and H asks, on what open intervals is the function h of x increasing and concave upward? Alright, increasing and concave upward. So we're looking for those two values. Where is the value increasing and concave upward? So what we're looking at is we need this part to be h prime of x. Well, we know that h prime of x, back from original what we were looking at, h prime of x is f of x minus 1. And we want h of x, I'm going to just do this, be greater than 0. But if we look at this, f of x minus 1 has to be greater than 0, which means the function value has to be greater than 1. And concave upward, which means the slopes of f are increasing or positive. So what we're going to do is we're going to go to the graph as soon as I find my graph. And we're going to go wherever f is greater than 1, so it's right there. And what I'm going to do is I'm going to use a little bit darker pen so I can see and make sure that I have it on here. So we're going to go right across. This is where f of x is greater than 0. So I'm only looking at this part, and then I need the part where it is increasing. That's decreasing. This part and that part. So what are those two times? Well, those two, oh, that's halfway in between. And we know that's halfway in between because if we looked at the slope is going to be right 1 and up 2, or we can go right a half and up 1. So that point right there is going to be the interval from negative 1.5 to negative 1. Okay, x values. And from, oh, there's another half, 2.5 to 3. Those are the values where that is increasing and concave upward. All right, and I limit as x approaches 1 of k of x plus arctan of x all over 2x minus h of x minus 3. You need to check to see if L'Hopital's rule applies. We're going to get in our little time machine and fast forward. Okay, so hey, L'Hopital's rule applies. I know. You can do it. I know you can. The limit, check that limit. Check the other limit. It both go to 0. Okay, so what we are going to do is we're going to take the derivative of the top, the numerator. And the derivative of the numerator is k prime of x plus, this is one of those arc tangents derivatives, and that's one that should be on your little cheat sheet that you're going to do. And then on the bottom is going to be 2, because the derivative of 2x is that, minus this would be h prime of x minus 3 times the derivative of this, which is 1, so that can leave. And then what we're going to do is we're going to plug in 1, and we're going to see if that works. Oh, okay. Do we know what k prime of negative 1 is? Or excuse me, k prime of 1. So k prime of 1, we found that to be, well, where was that? That was back, way back at, oh, way back here. K prime of negative 1 is negative 1. Go in the way back time machine. Plus 1/2 over 2. What's h prime of negative 2? That's a negative 1. All right, so we got negative 1/2 over 3, which is negative 1/6. Holy cow. All right, so use L'Hopital's rule. Evaluate that. We get negative 1/6. Yes, k and h all pertain to that equation because you have so many different things that go along with it. All right, so make sure that you're watching those videos. I'm going to slide over. I'm going to do Stinger. Hold on. Stinger just, oh, it's not too impressive. Not like the swipe or the other one. So I'm done with those videos. If you have any questions on the graphical stem, let me know. Watch them at your leisure. This one 14-minute video is going to go along with the 16-minute video of the first section. So I split it up and I was able to trim off the other part. So this is question or part 3, or E through A, or E through I. So it's this part is what the video is showing us. Okay? Have a good day, night, morning, whatever you're watching this, and we'll see you later. Bye.